Everybody, it's Tyler here at Chezy Champs, checking in with team number 973, Greybots, coming in from California. I'm here with Joseph, Charlotte, and Tanner, and we're going to be talking, of course, this awesome robot. This is really leftover from 2020. A lot of stuff hasn't changed from them, but they have some fantastic mechanisms. They're going through, of course, taking us through the intake, following that power cell journey, talking about Climber, all this and more coming up here on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We'd like to thank Stryker for their continued support of First Updates Now. Stryker's internship portal is now open and available. Discover internships and rotational programs located around the world, including their headquarters in Michigan, when you go to careers.stryker.com and click on Students and Graduates. We'd also like to thank Kettering University. Kettering University is where robotics students come for their education. Over 30% of those who attend Kettering University were in high school robotics, and you can keep going with their BattleBots, VexU, esports, and First Mentorship programs. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12th, 2021. So starting out on the intake here, you guys have a fantastic wide intake. Greybots, when they pop in my head, I always think about just really effective collection mechanisms every single year that I see. So talk to me about some of the design, the thought process, iterations, and what maybe like materials you're using on this as well.
So we wanted an intake that could get balls from like anywhere on the bumpers, and so it'd be really easy to intake a ball from the ground. So it didn't take a lot of driver precision, and it would be fast and effective under defense. As for the design, we want to make these really robust because you can either make an intake really flexible or really strong.
Yeah.
And so we chose really strong because that's what we're better at. That's what we've done in the past. That's how we know how to do it. And we pocketed it to save weight. And as for the materials, we iterated a little bit. We found these wheels on this roller worked pretty well, but this worked best. We used it in 2019 for a little while. It worked really well.
What is this material that you guys are using?
I don't remember what it's called, but some sort of rubber.
Okay.
We like clean it off every match, and so we keep it clean and sticky and everything. It does get bent, but we unbend it. So.
Can we see the intake come down when we put like a power cell in as well?
Yeah, enable. All right. So you can put a power cell in, and it's really fast and it works every time. The balls don't really fly out. So.
This area here that we have, like the zip ties and this material, was this part of the initial robot, or was this kind of like added on after the fact, like were power cells popping out or anything like that?
Well, initially at the first iteration, before like LA North, these weren't here.
Sure.
And so they flew out and everything. They still sometimes will fall out the sides. But we put these here to keep them from falling out the top. And sometimes the intake will be so powerful, it'll hit the back of the belts right here and make them go, like, get stuck. And so that's why this plate back here is up here, and this top plate keeps them from falling out. So it's just like a big hopper where the balls cannot fall out of the robot, really. So it keeps them under control.
Well, let's keep moving on. We'll talk about in that hopper here. You got a nice, very wide hopper. Talk to me about really some of the process you went through, and how did you look at like preventing jamming in the power cells and trying to work through that as well?
So originally we had designed a few like really like polycarb things that were kind of weird shaped, and they would go back here and like effectively manage the power cells, and that didn't work at all. So we used what they used in like industry, which is just like two ramps like that. And it works really well. Once in a while, two of them will bridge there, and we just shake around, and they get unjammed. But overall, it works really well.
I do want to ask, as it's coming through, I know that you do have some sensors in your robot. Some are actually working and functioning right now, and some are not. But I do see what looks like a photo gate kind of on the bottom there. Is that something that you all are using currently right now?
Currently, no, but we have gone to work. I'm pretty sure we got to work at LA North. It's supposed to detect the power cells and kind of like automate the indexing. Make it easier for the co-driver, make it not jam.
Do you mind talking about maybe like some of the process you went through? Like, where did you struggle for it, and how did you learn from that as well?
So originally we wanted to be able to, especially in our auto modes, we wanted to be able to tell where every ball was and how to most effectively shoot them and like organize them. However, the sensors weren't completely accurate based on like their placement and just like. Yeah, it was mostly like their placement and us figuring out how to effectively create an algorithm they can figure out where the balls are and how we can feed them in and index them.
And you had another one that was kind of up here as
Yeah.
well too, right? So kind of the same thing.
So we wanted to have one near the intake, at the base of the tower, and at the top of the tower.
Yeah.
However, we couldn't figure out a very good algorithm for that, and I don't think we used it during LA North, and we sort of just decided to work on other things instead of that.
And one of the reasons I always bring this up, I like to talk about this with world-class teams. You know, 973 world champions in the past. And I think it's important for all teams to know that all teams have different things that work. Some things do and some things don't. And it's about how you handle that and continue to move forward and continue success as well. So I appreciate that candid feedback on that as well, because it is important for all teams to know that, you know, everybody's going to go through ups and downs for things, and how you handle it is very important. So let's continue moving on. Is there anything else on that this kind of hopper area we want to talk about, or do we want to go straight into the shooter?
We could go straight into the shooter.
Okay, let's talk a little bit more about, of course, massive set of wheels here that you have. I'd love to hear more about your hood as well, too.
All right, so we prototyped a couple different kinds of shooters. We've done shooters before in like 2017, and we used a similar design where we have the feeder wheels, which will speed the ball up just a little bit to some arbitrary speed, and then the big flywheel will speed it up to the correct speed, and it will make the shot more accurate since it's already sped up some.
Sure.
So that's why we did that's what the top black wheel and the big shooter wheels for. The bottom black wheels, we call it the cure wheel. It keeps the balls from going up if you run the thing too high, the tower. And so it keeps them from shooting in the middle of the match.
Is this a fixed hood that you're using, or does it adjust at all?
It's fixed. We wanted to keep this robot simple. We knew we didn't have the resources to build a big complex robot with a turn adjustable hood and a swerve drive and everything. So we just kept it simple. And so one hood angle can shoot from a pretty big range of spots. And we're implementing at this competition a new thing that changes the speed of the flywheel based on the distance away from the goal. And Charlotte can talk more about that.
Yeah, let's talk more about how are you using different sensors, cameras, that sort of thing to dictate all that.
Yeah, actually, this is a more recent implementation. We use the limelight to determine the distance from the goal, and based on that, we change the flywheel RPM. So obviously, if we're closer, it'll lower the RPM. If we get farther, as we get farther and farther away, it'll increase it. And at a certain distance, since the limelight can't, I think it's around the trench area, the limelight will stop reading the distance, and we set it to a very specific, higher RPM speed.
Sure.
So.
I do want to ask in the other side as well here too. We have a camera here, and then are these feedback LEDs, or what are they actually used for?
Yeah, these were feedback LEDs. They were originally meant to determine to tell the driver and co-driver the speed of the flywheel.
Oh, okay. So can you talk about how is the drive team actually using it? What are they seeing when that happens?
So initially we had red LEDs, and then it made the orange light look like the LEDs, and so we changed them to green. And if we can run them, that'd be pretty cool. But when the flywheel is spinning up to speed, they're flashing green, and when it's up to speed, it's solid green. So since the shooter's on that side of the robot, we can't really see it. So from the driver's perspective,
let's see if we can find a way to get the LEDs going on here. We'll check that out too.
Yeah.
There we go.
It looks like they don't flash. All right, but when it's up to speed, they are solid green, and so that tells me, the driver, that it's up to speed and I can shoot. And it also, in software, does not let me shoot until they're ready. So that's kind of an added bonus.
We're going to talk about your climber in a second. I actually want to talk a little bit about your driver station and the controllers that you're using for that. Actually, I just noticed that on there. Those are a little bit different than I've seen many other teams utilize. So how are you driving and operating? Can you talk about that a little bit more?
Yeah, here. All right. So I drive using these sticks. So it's split arcade, so forward, backward, and then left, right, but we use the Chezy drive, so you gotta be moving forward. And this just left, right sets your velocity left, right. And so if you just push this, it doesn't go anywhere. And it automatically scales your turning, so it gives you more accurate turns and can make you drive in arcs versus just like go, stop, turn, stop, and like that.
I haven't seen something, a lot of teams are, of course, for many years been using more like Xbox controllers, PS5 controllers, stuff like that. So I just think it's super cool to see what you've been using. For myself and cameraman Eric here, that it's like old school deals going on back over there. So it's super cool to see that being implemented as well.
yeah, it just gives us more precision with the driving, and there's buttons back here too.
Very cool. Well, let's wrap up on your robot, talk about your climber a little bit more. If you don't mind, let's talk about, is it just a single stage? And talk to me about some of the torsion springs, some of that stuff going into it.
Yeah, so it's just a single stage. It's powered by a constant force spring that pretty much goes all the way to the bottom, and then that just holds a constant force on it. And then these ropes here, yeah, they go all the way down, and they're connected to a spool, which is powered by a motor. So the string pretty much holds the tension from the constant force spring, and then when we want to climb, we just undo the spool and it goes up, and then it's pretty quick, and we can just pull it down pretty fast once it's up there. And so that's part of how we can climb so fast.
Well, 973 Greybots, been making great robots, of course, world champions in the past as well, too. So thanks for taking time to show us more about this robot. Of course, can't wait to see the results of Chezy Champs afterwards, but looking forward to your team in future years as well. Thanks a lot for taking the time. Thanks to Kettering University for their support of this video. Don't just sit in class. Kettering University is the only school in the U.S. that allows you to work as an engineer your first year with their 3-month on, 3-month off co-op programs. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12th, 2021. We'd like to thank Stryker for their continued support of First Updates Now. Stryker's internship portal is now open and available. Discover internships and rotational programs located around the world, including their headquarters in Michigan, when you go to careers.stryker.com and click on Students and Graduates. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.